Hello students, welcome back to the channel. In this video, we are going to study about the anatomical dead space, what is its value, how to calculate minute ventilation and how to calculate alveolar ventilation. So these are the three topics which I will be trying to explain you through this video. So first of all, the air has to reach to the alveoli through the passage, that path which starts from the external nostril, then comes the nasopharynx area, then comes the trachea. From trachea, trachea will branching into the bronchi, which is primary, secondary, and tertiary bronchi, which will divide to form bronchioles. That is your initial bronchiole, terminal bronchiole, and respiratory bronchioles. And then through alveolar duct, it will reach to the alveolar sac. And alveolar sac has many alveoli, and alveoli are the main site for the gaseous exchange. This much you know very well. So conducting zone consists from the external nostril till terminal bronchiole. You can see it in the diagram. This is the one. Till terminal bronchiole is your conducting zone. Your respiratory zone, please focus the board. Respiratory zone is from the respiratory bronchiole, alveolar duct, and alveolar sac. These are the one which are in the respiratory zone, where the actual exchange will occur. But in that, primary the site is alveoli. Now, what is the air which we take in during normal breathing? That we say it is a tidal volume. But the one which is able to reach to the alveoli, we will find that only 70% of the tidal volume is able to reach. So if you see in a typical adult, only 70% of the tidal volume means 350 ml. Total is 500 ml now. Tidal volume total is 500 ml, of which 70% means 350 ml is only able to reach to the respiratory zone. Is it clear? And it is participating in the gaseous exchange. Remaining 30%. 30% means 150 will be present in the conducting zone. And conducting zone starts from the external nostril till terminal bronchiole. Clear, beta? Till terminal bronchiole. You can see the sequence is given here till terminal bronchiole. And this 150 ml volume of air which is present in the conducting zone is known as anatomical dead space. This is very important. Please understand, anatomical dead space value is 30% of the total tidal volume. If tidal volume is 500, it means 150 ml is your anatomical dead space. 150 will be trapped here only. And it contains air which does not undergo gaseous exchange. That is why all minute ventilation, means all which is the 1 minute ventilation, in 1 minute you're doing it, is not used for gaseous exchange. Why? Because some of it is remaining in the anatomical dead space. So if they ask you the numerical questions by giving you any volume, suppose they give it 600 ml is a tidal volume, then you have to calculate 30% will be anatomical dead space. So please remember, 30% of tidal volume is your anatomical dead space. Clear, beta? And it is the air which is trapped in the conducting zone. So this is the one area where the students do mistake. I hope so this topic is easy for you. Now see, if they ask you how to calculate the minute ventilation, formula is given here. Minute ventilation is equal to tidal volume. Tidal volume is amount of air taken per breath. And what is respiratory rate per minute? Suppose we are taking a tidal volume. Okay, this is the tidal volume and this is the respiratory rate. Will give you the minute ventilation. Clear? Suppose the tidal volume is 500. And respiratory rate means how much you are breathing per minute. If suppose you are breathing 12 per minute, what is your minute ventilation will come? I think so you can do immediately calculation. Answer will come this much. Either answer will be you will write in the ml because it is in the ml per minute. Clear, beta? Or you can convert it into the liter per minute. So formula you have to remember, this is the one formula. Ki tidal volume multiplied by respiratory rate. Respiratory rate means number of breath per minute. How many breath person is doing in 1 minute? Clear? This is one formula for the minute ventilation. Now see what is formula for how to calculate alveolar ventilation. Alveolar ventilation means how much air is able to reach to the alveoli. Is it clear? So what is the formula for this? This is the formula given. Means you have to take tidal volume. From this you have to subtract the anatomical dead space volume and this multiplied by respiratory rate. Suppose your tidal volume is 500, anatomical dead space is 150. Clear? And this you have to multiply by breath. Let us assume we are taking 12 breath per minute. So you can calculate the one which is able to reach to the alveoli is 350 multiplied by 12. Your answer will come nearly 4200 ml per minute. Clear, beta? So this is your alveolar ventilation. So answer will be this much. And I hope so I've given you this explanation how to solve it. You have to take the tidal volume. From this, you have to subtract the dead space volume, anatomical dead space, and number of breath per minute. You do this, you will get the answer. What is the alveolar ventilation? So I hope so numerical questions based on these topics might be now easy for you. Thanks for watching.